Okay, now we're dealing with rectangles. Rectangles are just another form of parallelogram, so it's kind of the same deal. We got a couple things we know about rectangles that are not necessarily true about every parallelogram, and that would be the diagonals. Well, first of all, rectangles got right angles. That's pretty obvious, I think, for rectangles. But here's one that's not so obvious, is that the diagonals, yeah, they bisect each other because there's a parallelogram, but they're also equal to each other in length. So RT and SU are actually equal to each other. And they bisect each other, which means all four of these segments of these diagonals right here are all going to be the same. And that's true for every rectangle. All right, so let's keep that in mind as we do this, at least the first two problems anyway. So let's take a look at number 10. It says if RZ is 3x plus 8, RZ is this one right here. That's 3x plus 8, and ZS is this one right here. Remember, these two segments are equal to each other, aren't they? Find UZ, and so we're trying to look for this one. Well, really, if I can find either this one or this one right here, RZ or SZ, I've got UZ. It doesn't matter which of these three we actually solve for. They're all going to be the same number. So let's do this. What's true? What's the relationship between RZ and ZS? Well, they're equal to each other, so we set these equal to each other. I don't know. When I set them equal to each other, I like the larger one to be on the left-hand side. It just makes my algebra a little bit easier. So I set them equal to each other. And I go ahead and I solve. Subtract 3x from both sides. 6x minus 3x is 3x. And add a 28 to both sides. And what is that? 36, I believe. Divide both sides by 3. So if I divide this by 3, I get 12. So x is 12. That's not my answer, though, because they asked to find UZ, which is one of the sides. Look, I could find, I'm not really finding UZ directly, I'm finding either one of these, and it's going to be the same thing. So I could either put that x in for this one or this one. Which do you think would be easier? I think RZ would be easier. So let's put the 12 in for that. So RZ is 3x plus 8. Let's put in what the x is. That's a 12. So it's just 36 plus 8, and that is 44. So you're saying, yeah, but we solve for RZ. But RZ and ZS and UZ are all the exact same thing. So we can find either one of these, and UZ is going to be the same number, so it's 44. Okay, number 11 has to do with the diagonals also, but a little bit differently. Look, it says RT is 5x plus 8. RT is the whole thing from here all the way down. Then it also tells you, oops, I erased the Z. That's supposed to be a Z right there at this point. All right, so RT is 5x plus 8, which is the whole thing right there. And RZ, I just want to look at the relationship between RT and RZ. Look, RT, remember they bisect each other. RT is going to be exactly twice as big as RZ. And in fact, I'm going to write that down. I'm going to write RT is twice as big, or 2 times, RZ. That's going to help me with my math. And that's our relationship. That's what we are going to set up as our relationship. It says find what ZT is. So we're just finding this little bit right here. Really, if we find RZ, it's the same thing as ZT. So again, we're not really finding ZT directly. We're finding what RZ is, understanding that these are going to be exactly the same number. So really, I'm just solving for RZ, aren't I? So let's plug some stuff in and see what they tell us. RT is 5x plus 8, so we put that in here, 5x plus 8. Equals 2 times RZ. RZ is 4x plus 2. I'm sorry, getting ahead of myself. 4x plus 1. And then we're going to go ahead and solve for x here. Let's do that. Distribute the 2. That's 8x plus 2. That's why I said 2 earlier, because I knew that was going to get 2. Let's do this. Subtract a 5x from both sides. We get a 3x. Subtract a 2 from both sides, and we get a 6. Divide both sides by 3. Oops, it's not plus. Why did I do that? I don't know. Divide both sides by 3, and x equals 2. Now that's not what the answer is, because we have to find what ZT is. Remember, we're finding this or this. Let's look for RZ. Remember what RZ was? It was 4x plus 1, so let's put that into that. So 4x plus, oops, let's put that in parentheses. There's 4x plus 1. I'm going to take that x, and I'm going to put it in right here. So that's 8 plus 1, which is 9. So RZ was 9 right here, but they asked for ZT. Remember, they're both going to be exactly the same thing. So they're both going to be 9. So I'm just going to write ZT is equal to 9 as well. All right, now we're dealing with the same picture, but now we're going to talk about the angles. So let's take a look at these. SRT. Let's mark where SRT is. There's SRT. So I'm going to mark it right on my picture. It's easier to visualize. And then UTR. UTR. R, that would be this one down here. Now look, I can put arcs for both of them, one single arc, because remember, a rectangle is a parallelogram. These are parallel sides. These would be alternate interior angles. Alternate interior angles are equal to each other, so we can actually say that they're equal to each other. So that's nice to know. And what are we trying to solve for? UTR. Where's that? Oh, this one down here. So we're just trying to find what that angle is. So what we're going to do is set them equal to each other. Why? Because alternate interior angles are equal, and so we can set them equal to each other. So I'm going to go x plus 9 equals this angle right here, which is 2x minus 44. And now we just do some math and we solve. Subtract x from both sides, that's going to give you x. Add the 44 to both sides, and that's going to give you 53. That's what x is equal to. But we're not trying to solve for x, we're trying to find this angle right here, which is UTR. So we know what x is, so what we're going to do is we're going to come in and put it right there. So it's going to be 2 times x minus 44. And put it in here. What we said it's 53, right? Yep, x is 53. So you do this math, that's 106 minus 44, and that's going to give you 62. All right, and that's angle UTR, angle UTR. And it's degrees. We'll put the degree symbol. All right, one more of these. This last problem is kind of like the one we just did, so it shouldn't be that hard to follow. RSU. RSU is this angle right here. And then TUS, where's T, then U, then S. Now look, they're also alternate interior angles, just like we had earlier. Now they're two different angles, but it's the same idea. Find RSU. So find this angle right here. Almost an identical problem to number 12. Guess I should have mixed them up a little bit better, shouldn't I? But that's what was on the test, so that's what we're going to do. So we set these equal to each other. It's good practice. So x plus 41 equals 3x plus 9. Solve for x. Subtract x from both sides. I get a 2x. Subtract a 9 from both sides, and I get a 32. Divide both sides by 2. 32 divided by 2 is 16. X is 16. We have to find RSU. Here's our angle right here, RSU. So it's just 16 plus 41, and that is 57. So angle RSU is equal to 57 degrees. Almost identical to number 12. Okay, we're going to do a little more with rectangles. It's a little bit different, but not a whole lot. Not as much algebra in this. So they say solve for angle 2 and 4, and they tell you what angle 1 is equal to. So angle 1 right here is 37 degrees. So, gotta change this again, I forgot. Okay, let's try this again. Angle 1 is 37 degrees, so that is 37 degrees right here. It says it's a rectangle, so we know that this must be a right angle. So if this is 37 degrees, this angle right here is 90 minus 37. 90 minus 37 is 53 degrees, so angle 2 is 53 degrees. It also asks for angle 4. Notice, these are alternate interior angles with each other. Parallel lines, cut by transversal, the whole deal. We've talked about that before. So that must be 37 degrees as well. That's all there is to that. Not that hard at all. Okay, now we're talking about a rhombus this time. Still a parallelogram, but it's a rhombus. A rhombus is all 4 sides equal to each other. Now this kind of looks like a square. It doesn't necessarily have to be a square. But all 4 sides are equal to each other. What else is true about a rhombus? Well, the diagonals bisect each other because it's a parallelogram, but also it forms a right angle. Okay, they're perpendicular. Diagonals are perpendicular to each other. So that's a right angle right there. It's hard to tell from that little picture, but you get the idea. That's a right angle. All right. Oh, what else happens? The diagonals, the angles that are opposite each other are also bisected. Okay, so now it's a parallelogram, so the opposite angles are equal, but not on every parallelogram does the diagonal bisect the angles. But on a rhombus, it's true. The angles are bisected, so keep that in mind as well. Let's look at the first thing. It says RK is 5, so this is RK. We'll make that 5. RY, which is right here, which is 13, and we're trying to solve for KY. KY is this. Let's just call it X, just to make it easy. Now, if you take a look at this, it's a right triangle. And I don't know if I'm going to be able to draw this very well, but it looks something like that. So there's 5 and there's 13, and you have to find what this is. Well, this is one of those special triangles. You could use Pythagorean theorem, but it's one of those nice things, like 3, 4, 5. You remember that one? It's the same kind of deal. It's 5, what? 12, 13. That makes it very convenient to remember your special triangles, 5, 12, 13. Or you can do Pythagorean theorem, and you can see you'll get the same exact value. Just easier, knowing it's a special triangle. All right, let's look at this. Angle YZR. I'll tell you what, let me clear all this junk out of here. All right, that looks a little better. Let's write this down. Angle YRZ is 67 degrees. Here's YRZ. It's this angle right here is 67 degrees. And it asks to find YZR. Where's that? There's YZR. It's asking for this angle right here. Well, remember, they're bisected. So this is 67, so is this, so is this, and so is this. So when you have a rhombus, all four of these angles are exactly the same. You don't even have to do any math. You can just look at it and say, okay, it's 67 degrees. And that's my answer.